For centuries, the icy frontiers of the North and South Poles have captivated the human spirit. These desolate and unforgiving landscapes have beckoned explorers, each driven by an insatiable thirst for discovery. The North Pole, a geographically unique point in the Arctic Ocean, was the target of many daring expeditions. Names like Robert Peary, Frederick Cook, and Roald Amundsen are forever etched in the annals of polar exploration, their journeys testaments to human courage and resilience. The South Pole, on the other hand, presented a different set of challenges. Located at the bottom of the world, on the continent of Antarctica, it remained hidden beneath layers of ice and snow for much longer. Finally, in 1911, Norwegian explorer Roald Amundsen and his team won the race to the South Pole, followed shortly after by Robert Falcon Scott's British expedition. These early expeditions, fraught with danger and hardship, marked the beginning of our fascination with Earth's polar regions. These pioneers ventured into the unknown, driven by a desire to map the world, unlock the secrets held within the ice, and push the boundaries of human endeavor. Their stories, filled with tales of bravery, tragedy, and triumph, continue to inspire awe. They laid the groundwork for our scientific understanding of these extreme environments. However, their explorations were just the beginning. Today, the focus has shifted from mere exploration to understanding the crucial role these icy regions play in regulating our planet's climate. The United States has long recognized the importance of the Arctic, not just as a geopolitical frontier, but as a critical region for scientific research. This vast, icy expanse holds many secrets that are crucial for understanding our planet's past, present, and future. From early expeditions to establish a presence in the Arctic to modern-day research stations, the U.S. has played a pivotal role in unraveling the secrets of this icy realm. These early explorers laid the groundwork for the sophisticated scientific endeavors that would follow, mapping uncharted territories and enduring extreme conditions. One of the most ambitious U.S. efforts in the Arctic was the establishment of a network of research stations, including the iconic Camp Sentry under the Greenland ice sheet. This station, built during the Cold War, was not only a feat of engineering, but also a hub for groundbreaking scientific research. These stations, often operating in the harshest of conditions, have served as vital outposts for scientists studying a wide range of disciplines. The extreme environment of the Arctic provides a unique natural laboratory for researchers to conduct experiments and gather data that would be impossible to obtain elsewhere. From glaciology and oceanography to atmospheric science and biology, the research conducted at these stations has significantly advanced our understanding of the Arctic. Each discipline contributes a piece to the puzzle, helping to create a comprehensive picture of this complex and dynamic region. The U.S. has also been at the forefront of developing innovative technologies for Arctic research. These advancements have enabled scientists to push the boundaries of what is possible, allowing for more detailed and accurate studies. From icebreakers capable of navigating through thick sea ice to sophisticated remote sensing instruments, these technologies have allowed scientists to study the Arctic in unprecedented detail. The ability to remotely monitor and collect data has opened up new avenues for research, making it possible to observe changes over time and across vast areas. For instance, the use of satellites and aircraft equipped with specialized sensors has revolutionized our ability to monitor changes in sea ice cover, glacier melt, and other critical climate indicators. This technology provides real-time data that is essential for understanding the rapid changes occurring in the Arctic. The data collected by U.S. researchers in the Arctic has been instrumental in shaping our understanding of global climate change. These findings have informed policy decisions and helped to raise awareness about the urgent need to address climate issues. The Arctic is warming at a rate faster than any other region on Earth, and the consequences of this warming are far-reaching. The loss of sea ice and the thawing of permafrost are just the beginning. These changes have the potential to trigger feedback loops that could accelerate global warming. The melting of Arctic sea ice, the thawing of permafrost, and the changes in ocean currents all have profound implications for the planet's climate system. These changes can alter weather patterns, impact marine ecosystems, and even affect global sea levels, making the Arctic a critical area of study for scientists around the world. While the Arctic may be Earth's northern refrigerator, It is the South Pole that holds the key to understanding our planet's climatic history. The South Pole, resting on the continent of Antarctica, acts as a giant frozen archive of our planet's climatic past, preserving invaluable data within its icy depths. Trapped within its vast ice sheets and glaciers are ancient air bubbles, preserved for millennia, offering a unique glimpse into the Earth's atmospheric conditions from long ago. These bubbles are like tiny time capsules, holding within them secrets of Earth's atmosphere from long ago, providing a direct link to the past. Scientists extract these ice cores, drilling deep into the ice sheet, retrieving cylinders of ice that can be tens of thousands of years old, each layer representing a different era in Earth's history. By analyzing the composition of these ancient air bubbles, researchers can determine past concentrations of greenhouse gases like carbon dioxide and methane, which are crucial indicators of climate change. These measurements provide a stark picture of Earth's climate history, showing how greenhouse gas levels have fluctuated naturally over time, and how they correlate with temperature changes. But the real significance of the South Pole's climate record lies in its stark warning about the present, highlighting the unprecedented changes we are witnessing today. The ice cores reveal that current levels of greenhouse gases in the atmosphere are unprecedented in human history, far exceeding natural fluctuations observed in the past. The rate at which these levels have risen, particularly since the Industrial Revolution, is alarmingly rapid, driven by human activities such as burning fossil fuels and deforestation. This data from the South Pole's icy depths serves as a stark reminder of the profound impact human activities are having on our planet's delicate climate balance, urging us to take immediate action. The South Pole's ice also holds clues about past temperatures, providing further evidence of a warming planet and the intricate relationship between temperature and greenhouse gas levels. Scientists analyze the ice itself, looking at the ratio of different isotopes of oxygen and hydrogen within the water molecules, which can reveal the temperature at the time the snow fell and eventually form the ice. This ratio is directly related to the temperature at the time the snow fell and eventually formed the ice, providing a detailed record of past climate conditions. These temperature reconstructions, when combined with the greenhouse gas data, paint a comprehensive picture of Earth's climate history, highlighting the close link between greenhouse gas concentrations and global temperatures, and underscoring the urgent need to address climate change. Our planet is experiencing a fever, and the thermometer readings are undeniable. The data is clear and consistent, showing a relentless upward trend in global temperatures. The global average temperature is steadily climbing, a clear signal of the profound changes underway in Earth's climate system. This rise is not just a number, it represents a significant shift in the balance of our planet's delicate climate. This warming trend, driven primarily by human activities, is particularly pronounced in the polar regions, which are heating up at a rate 2 to 3 times faster than the global average. The ice caps and glaciers, which have existed for millennia, are now melting at unprecedented rates. The primary culprit behind this warming is the increased concentration of greenhouse gases in the atmosphere. These gases, such as carbon dioxide and methane, are byproducts of industrial activities and the burning of fossil fuels. Carbon dioxide, methane, and nitrous oxide, released into the atmosphere through the burning of fossil fuels, deforestation, and other human activities, trap heat and prevent it from escaping back into space. This accumulation of greenhouse gases is altering the natural greenhouse effect. This trapping of heat, known as the greenhouse effect, is essential for life on Earth. But the enhanced greenhouse effect, caused by human activities, is pushing the planet's temperature beyond its natural limits. The balance that has sustained life for thousands of years is now being disrupted. The consequences of this global warming are far-reaching and potentially catastrophic. We are already witnessing an increase in the frequency and intensity of natural disasters, such as hurricanes, wildfires, and floods. Rising temperatures are melting glaciers and ice sheets at an alarming rate, contributing to sea level rise and threatening coastal communities around the world. These changes are not just affecting remote areas, they are impacting millions of people living in coastal regions. Changes in precipitation patterns are disrupting agricultural yields, increasing the frequency and intensity of droughts in some regions and floods in others. This variability in weather patterns is making it difficult for farmers to predict and plan their crops. Warmer temperatures are also exacerbating heat waves, leading to heat-related illnesses and deaths, particularly in vulnerable populations. Elderly people, children, and those with pre-existing health conditions are at greater risk. The warming trend is also disrupting ecosystems, pushing many species to the brink of extinction. Animals that have adapted to specific climates are finding it increasingly difficult to survive as their habitats change. As temperatures rise and precipitation patterns change, habitats are altered, forcing species to adapt or migrate. This migration can lead to conflicts with human populations and other species, further complicating the survival of these animals. Some species are unable to keep up with the rapid pace of change and face an uncertain future. The loss of biodiversity is not just a loss for the natural world, but it also has profound implications for human well-being. The warming planet is a stark reminder that we are living in an interconnected world, where changes in one part of the system can have ripple effects across the globe. The actions we take today will determine the future of our planet and the legacy we leave for future generations.